In our last video, we demonstrated a more robust way to set initial values for model parameters. In this video, we will add a second model parameter to our example model. This parameter, which we will set up to model rut progression, will be a function of, that is, dependent on, surface age. If you want to follow along with this video in a hands-on way, please have a look at the preceding videos in this series before you try to follow along in this video. In the previous videos, there are several concepts that have been introduced, and I'm going to assume that you're already familiar with those concepts in this video. And if you have not watched the preceding videos already, then this video may be quite confusing for you. So let's go and have a look at our DMS file and add another parameter. So here we have our DMS file, and I'm on the parameter sheet. And I'm going to add another parameter just as we did in one of our preceding videos when we added the surface age parameter. So I'm going to just copy this column and I'm going to paste it. And I'm going to call this simply rut. So this parameter will be called rut. And now I just have to go and fill in these values over here. So I've got this as a number, and this is going to be a millimeter indicator. And the decimals I will set to 1. So we'll show 1 decimal on the rut depth parameter in display tables and so forth. These are the placeholders where GeoViewer will add as it cycles through all of the treatment lengths, it will add the current rut depth at the start of the year, and then after it's calculated the increment, it will add this for at the end of the year. Now, these placeholders can be used by other parameters. So, for example, for the rut depth, we can use the placeholders for surface age, which we have previously showed in our other videos that these are named ranges. And I'm just going to do the same now for rut depth. I'm going to name these placeholders so that I can easily refer to them in formulas. So I'm going to go to the Formulas tab, and I go to Define Name. And because this is a parameter, I use the convention of PAR and rut. So this is parameter rut. And at the end of the year placeholder, I similarly define a name, and I'm going to call this PAR rut end, meaning that's a rut at the end of the year. You can use any names, and you don't have to follow the convention that I'm doing here, but I strongly suggest that you adopt the convention here because it will make your code and your model much more explanatory as you work through it. Okay, so where does the initial value for this parameter come from? Now, I want to use the same process that I used in the preceding video, in which I'm referring to a value that has already been checked in this DMS file. So I go to the info fields, and I'm simply going to take this surfacing parameter, and I'm going to copy this row and just paste it in there. And this is going to be the rut depth parameter then. And this refers, if I go back to the spreadsheet, which represents example of my forward works program table. So this is you can think of this as being a schematic representation of the forward works program table. Then this column here, that is the value that I actually want to use for the initial rut depth. So I'm going to copy that name, and I go back to my DMS file, and I'm going to just paste it in there. And this is going to be where the value will be filled in by the GeoViewer modeling engine. So I have to set this named range, and you can see that Excel automatically picks up the name in the cell to the left, which is exactly what I wanted to do, and that's also the reason why I first pasted that name in there. And I can click on OK. So now I've got a named range there. Now I have to put a default value. So if a value, insensible value for rut depth such as 999 comes in here, then I want to bracket it between these two values. So I'm going to say I will allow any rut depth between 0 and 30 millimeters. So you can see a value of 999 will be clipped to 70 in the final descriptor. However, what if something comes in like ABC? In this case, it will adopt the default value. That's the way that this formula is set up here in column G. So the default rut depth, I'm going to say, let's make it 8 millimeter rut depth. And I'm just going to put a comment in here. This is the rut depth in millimeter. Now the one other thing that I need to do is this finalized cleansed value for that is being extracted from the database. I want to give this a name, and again, just as I did with the surface age at the top, I'm going to prefix that name with IFIN, meaning it's an information item firstly, and secondly, it's a finalized value. So I'm going to name this cell IFIN rut. And this is then the value that I want my model to adopt as the initial value. So if I go back to the parameter sheet, then I'm going to say my rut depth initial value must come from an Excel equation, and that Excel equation is equal to the value in the cell IFIN. And you can see Excel suggests for me here the possible values. And I can use the tab key to select one of them. Just remember that, the tab key. And I'm going to do that. And you can see this auto-completion feature using named ranges makes it very easy to manage a complex model in your DMS file. So I'm going to press enter, and you can see it extracted that value 8 there from that named range. Okay, so now we can go on to the increment value. And the increment value, in the case of surfacing age, we had set that to a fixed value, that the surface age would increment with a value of 1 every year. However, in the case of rut depth, we want to make that rut depth actually dependent on surface age. So it will use the value that is currently at the start of the year that is being put into this placeholder value. And let's just take an example where we say we want the rut depth to be the square root of the surface age. So in that case, I'm going to make my increment equal to an Excel equation. I can delete that value. And what is the increment Excel equation? I have to put it in this row, and I'm going to say equal square root of parameter surf age, and that's a surfacing age at the start of the year. And I can now go and test that. So if my surfacing age is 0, my rut increment will be 0. If it is 4, then my rut increment, as you can see here, will be 2 millimeters per year. And if my surface age is 12, then my rut increment will be 3.46, and so forth. So that looks good, but I want to apply some sort of a calibration factor. So now I can do something that is very powerful. I can go and add a sheet. You are always welcome to add sheets to your DMS file, as long as you don't delete any of the sheets that were in the file at the start. So I'm going to add a sheet here, and I'm going to call this cal factors, for calibration factors. And I'm going to put in here a table like parameter, and I put in here K for calibration factor. And I'm going to put in a rut, and I'll put in a calibration factor of 0.1. Just make this a bit neat. I can also have perhaps something else in here, roughness, and maybe I can have a calibration factor of 0.44 and so forth. So now what I want to do is, from this calibration factor table, I want to select the calibration factor for the parameter rut, and I want to use that in my increment equation. So I'm just going to put in here, I look up that parameter name at the top, and I can see that parameter name is in my calibration factor sheet. And I'm going to say that I want to multiply this equation multiplied by a VLOOKUP, and I want to look up the rut parameter in the cal factors lookup. And I want to use the second column, and I want to use the exact lookup. So this is just a standard lookup function in Excel. So you can see in this case that rut depth increment has been modified to something slightly more realistic. So if I've got a surface age of 4, my rut increment will be 0.2 millimeters. If it is 22, for example, then my rut increment will be 4.7, which is a bit low. So let's just go and set this calibration factor maybe to 0.35. And then for a 20 millimeter, 22 years age, I will have quite a high rut increment. Now, of course, if you are using something like the HDM rut increment equation, then this equation will be more complex. However, the principles are all the same. You would simply be referring this increment to placeholder values that are to the left of the current parameter. So the HDM equation for rut depth, for example, is a function of mean annual precipitation, traffic intensity, and factors such as that. So those parameters you will have to set up first, and you will just simply refer to the placeholders of those parameters with your calibration factor and so forth. All right, so you can see if I've got, for example, a surface age of 8, then I've got to have a rut increment of 0.99 and so forth. I'm going to just push that calibration factor down a little bit, 0.25, and now I'll just set the color coding and interpretation. This parameter is also indirect performance relationship, meaning if the rut depth increases, performance goes down. So that's an indirect relationship, and my limit for severe I'll put at 15, and my limit for warning I'll put at 10 millimeters. And for now, I'm just not going to fill in all of these other parameters. They relate more to the automated reports that come out of the model, and we won't deal with that in this video. So now I'm ready to run my model with this new parameter added. So I make sure once again to save my DMS file, and then I can go back to Juno Viewer, and I go again to the settings menu, and I go to forecast models. I upload my modified DMS file. I check my model and I run it. Now that the model is finished running, I can go to the views menu and I can go and look at the outputs in the forecast view. And here my model is showing once again as the forecast for surface age. And what I want to do is to change this now to rut depth. So I actually want to view rut depth. So I go to this little wrench or spanner icon here, and I'm going to change my parameter. You can see Juno Viewer automatically picks up that you've now got a new parameter, and that parameter is rut. So I want to look at that parameter, and I'm going to apply that. And you can see here, this is now my rut depth. So you can see here I've got, for example, a 5 millimeter rut depth, a 5.8, and so forth. And you can see the color coding. If the rut goes above 10, it turns yellow, and if it goes above 15, it turns red. So with this model and this forecast view, it's now quite easy to see where I have treatment lengths that have very high rut depth and so forth. And by the way, if you want to see all the parameters together for a certain treatment length, you can always select that treatment length, and you can go to this little drawer icon here and look at the underlying model data. So here you can see all of the model data and look at it over all of the modeling years. So that's that little drawer icon. So in this video, we showed you how to add a model parameter for which the increments are dependent on one or more other model parameters. In our next video, we will start looking at treatments, how they are defined, and how to set up a simple trigger for a treatment. If you are following along with this video series and have any questions or comments, please feel free to contact us via email at info@lonrix.com. Thanks for watching.